Hello and welcome. This video is an addendum video explaining the two new additional models to Columbia Basin Research's program SampleSize in version 3.2.23. SampleSize is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration. SampleSize allows users to input a range of release sizes or parameter estimates to calculate the precision of survival projections and view those results via a graphical interface. Today, in this addendum video, I will briefly cover the new full and reduced ViRDCt models, which stands for Virtual Release Dead Fish Correction, used to estimate smolt survival from the face of a dam to the tailrace of the dam. If you've used previous versions of this program, you'll notice that there are two new models under the study type header, the ViRDCt Full model and the ViRDCt Reduce model. Note that if you'd like to run the single paired, virtual paired, or Ricker 2 release models, see SampleSize training videos number 1 through 5. If you click here, you can run the ViRDCt Full model. Note that there are no configuration options, and the one parameter of interest for which confidence intervals are calculated is the dam passage survival, SD. There are two releases for the ViRDCt model. V1 is the virtual release, consisting of fish detected at the dam face. D1 is the dead fish released in the dam tailrace. The parameters for the full ViRDCt model are as follows. SD is dam passage survival. Lambda is the joint probability of survival between tailrace and tailwater arrays and being detected at the tailwater array. Omega is the probability of the dead fish from D1 arriving at the tailrace array, and psi is the joint probability that a dead fish is washed down to the tailwater array from the tailrace array and is detected at the tailwater array. P1 is the probability of an alive V1 fish being detected at the tailrace array, and PD is the probability of detecting a dead fish at the tailrace array. For this exercise, let me put 500 to 600 into the virtual release V1, 200 into the dead fish release D1, SD of 0.995, lambda of 0.990, and omega of 0.3, psi of 0.15, a P1 of 0.98, and PD of 0.98. If you click Run Analysis, you can then look over your results table and results graph. More information on interpreting these results can be found in Program SampleSize videos number 1 through 5. I can then click out of that and I can click on the ViRDCt Reduced model. The Reduced ViRDCt model can be used if the dead tag fish releases are detected only at the tailrace array but not at the tailwater array. There are no configuration options, and the one parameter of interest for which confidence intervals are calculated is the dam passage survival, SD. The reduced model has the same two releases, V1 and D1, as described in the previous section for the full ViRDCt model. The parameters for the reduced ViRDCt model are SD, dam passage survival, lambda, joint probability of survival between tailrace and tailwater arrays and being detected at the tailwater array, phi, the joint probability of a dead released fish D1 arriving at the tailrace array and being detected at that array, P1, the probability of an alive V1 fish being detected at the tailrace. This has been a SampleSize addendum video covering the newly released ViRDCt full and reduced models. If you have any further questions on running through the program, we recommend watching videos 1 through 5 in the SampleSize training video series. We hope that this video helps you get the most out of program SampleSize. If you have any questions or comments in regard to program SampleSize, you can contact us at web@cbr.washington.edu. Best of luck with your study designs, and thank you.